There it is. Record on this computer. Okay, now it's recording. What is going on with this stuff today? Now I want to see the chat. There we go. Oh, that might have been the case. And it just somehow named somebody a host. Okay, weird. All right, so does everybody see this stuff about double integrals? Yes. Everybody blanked their screen too, except Julie. Can you see it, Julie?
I can see the note paper. Yes.
Okay. So this. Okay, good. I just want to make sure that's what y'all are seeing. All right, so double integrals. We'll have a lot of the similar stuff that we talked about in Cal 1. So here we have an integral of a function over a domain. Double integrals are limits of sums. Also used, we use what is considered the repeated use of the fundamental theorem of calculus part 1. So that's where we would have the definite integrals. This is an example of a integral of a function over a rectangle defined as a limit. So here we have what are the Riemann sums. And if you take the limit as these things go on forever and ever and ever, so we keep breaking them apart into like what are now these like rectangular prisms like they show on this picture. I didn't want to go through all that again. Where is that picture? So like what we did in Cal 1, sorry if I'm making y'all dizzy. So we had those rectangles, and now we're going to make these prisms, and then we end up just making a bunch of them, right? And as those start to have like infinitesimal volume, we're going to sum all those up to figure out that integral, right? Is that good?
Yep.
Makes sense.
Okay. Yeah. So I didn't want to go through all of that silliness. So let's try doing an iterated integral, which is a double integral. So if I do what's inside here first, this is all crooked now, hold on. So this is example 4 on page 865. Make this look straight to you. Okay, so what I'd want to do is worry about the first part. So if I just look at this piece right here. I can pull out the e to the x because I'll treat that as a constant. Now, if I integrate y with respect to dy, so his antiderivative would be I add 1 to the numerator or to the exponent and then divide by that exponent. So it'll be y squared divided by 2. And I'm going to evaluate where y equals 1 and y equals 9. So I get e to the x. And that's going to give me 81 minus 1 over 2. which is 40 e to the x, right?
Yeah.
Looks good? All right, so now I'm going to put this into the middle here of where this place was. So this is going to be the integral from 2 to 4 of 40 e to the x dx.
Can't you pull the 40 out?
You could. What is the antiderivative of e to the x?
E to the
E to the X.
E to the x. And I'm going to evaluate that from 2 to 4. Neat, right?
Pretty simple.
Let's try this one. So I can look at this as right? So if I worry about this part first, I'm going to rewrite this guy as 3 . How do I do this problem?
U substitution.
U substitution. So if I let u be 3x plus 4y, du is going to give me 3 dx, right? Because if I treat this guy as a constant. So if I look in general, this is going to be the integral of u to the negative 1/2. And then I don't have 3 dx, but if I divide by 3, I'll have du over 3. So that's the integral. Oh, sorry. That's going to give me u, if I add 2, so that'll be 1/2 divided by 3. But then I divide by that 1/2, so that's going to be multiplying by 2. So that's going to be 2u to the 1/2 over 3 plus c, right? Or make sure I did that right. Yeah, 2/3 root 3x plus 4y plus some c. So if I go back to this part and plug this stuff in, that becomes 2/3 3x plus 4y evaluated where x is equal to 0 and x is equal to 3. Which that comes out to be 2/3. That's going to be 9 plus 4y minus root 4y. Are we good with that? Do we believe that? Okay. So now I did the inside part. Let's do the outside part. So now I'm going to be integrating from 0 to 4 of 2/3 of, I'm going to write these as exponents, 9 plus 4y to the 1/2 minus 2y to the 1/2. I'll use the square bracket, dy. And see if y'all can find that for me. I'm gonna write these in a different color so we don't get all this messy. Then I divide by 4. Zero to 4. Okay. Nice. There we go. What's 5 cubed?
125.
There we go. And then square root, that's 8. So 9 square root is 3. 3 cubed is 27. All right. So, did you get these numbers? Wait, shouldn't that be? I have 61 there. Should be 64. That should be 64. Yeah. That doesn't make sense. 125 divided by, or sorry, minus 64 minus 27. Is that what y'all got?
Yes.
Awesome. Everybody else good?
Yep.
Cool. All right. Now the next example, show that we got this when we did this up here. But now would this be true if we did the integration with y first and then took the integration with respect to x? Is that true?
No.
Why?
Mm.
Well, if the functions are differentiable and they're continuous, I can do the derivative with respect to x and then with y is the same as taking the derivative with respect to y and then with x. So shouldn't I be able to integrate backwards, like switching them too?
I suppose.
And I think a CPA asked about this, or at least I thought about asking this. This is true because of Fubini's theorem. So if I did this problem again, oh, I wanted to switch these now. 304. So if I integrate this middle part, That comes out to be see when y'all integrate this part, do we get that part back? Oh, this should be dy. Come on, Joni. Let's see that.
Why were those two dx's changed to dys?
Oh, they shouldn't. I was looking backwards, sorry. They shouldn't be. Should be dx. Oh, yeah. The book has a typo. Again. There we go. So if I put in 3, that gives me 125. Take the square root of 9, 27. I'm going to put in 0 minus Did y'all get the same thing again? Okay, I just saw your comment
Which one?
about Captain Phillips.
Oh yeah.
It's what it feels like some days. So did this work for y'all? Did y'all get the same answer? Or y'all still working?
Still going.
Okay.
So is there an actual theorem for Fubinis, or is it just that you can flip them and it doesn't matter?
So for Fubini says that the double integral of a continuous function over some sort of domain or a rectangle. So that means I have a bound for my x's and my y, or bounds for my x's above and below, and a bound for my y's above and below. Then I could actually switch them as long as that function is continuous on there. So what that theorem is saying, so if I'm given some sort of, so here's my xy, here is y, here is x. So here's A, here's B, here's C, here's D. So I end up creating this box here. And if I have some function in there is continuous and differentiable, I can switch these guys. So it's just taking a snapshot of that function in those bounds. So it won't matter who I integrate with respect to first. Does that make sense?
Yeah, okay.
So did we get it? Or are we still working?
I got it.
You got it? What about you, AJ?
Yeah, I got it.
Cool.
No, he's making it up.
Yeah, I'm making it up 100%.
He chatted me privately and said he's just in bed. Doesn't even have notes out.
Can't even get away with faking it in here. Dang. But then again, you can't prove that I'm not.
That's true.
Did you record the thing?
Yes, this is recording.
Okay.
Just something happened to Fridays. I don't know what happened to it. So
Just wanted to remind you and possibly save the last 8 minutes of lecture just in case.
oh, okay. Yeah, those last 8 minutes. Well, in these last 8 minutes, I wanted to
So it really
kind of
matters.
do some logistics troubleshooting here with y'all. Let's see. How long does this problem have to do? Yeah, this one won't be long. Let's do this one and then we'll talk in the last couple minutes of class. All right, so I want to compute the volume of a graph of this thing over this rectangle 0, 3 cross 0, 1. So this is my X and these are my Y's. So this is essentially asking you to do the exact same thing. So I'm going to compute the integral 0 to 3, integral 0 to 1 of 16 x squared minus 3y squared dy dx. So then this piece, if I just calculate this inside part, so if I'm going to just look at from here on. So that's going to give me so that's going to make this a 16y minus x squared y minus y cubed evaluated from 0 to 1. So that's just going to give me 16 minus x squared minus 1 or 15 minus x squared. Cool? I didn't do that too fast, did I? I will take your silence as if we're okay.
So wait, would it matter if we
Switched it?
no, so for the rectangle, does it have to be that the first one is X and the second one is
Mhm.
Y?
Yeah.
Cool.
It's just so that way we know what order we're actually looking at these in. So we always assume X comes first and then Y, right? Because when we do the ordered pair, X comma Y, X is always first. Does that make sense?
Yeah.
Now, all I'm going to do is integrate from 0 to 3 of 15 minus x squared dx. So it'll be 15x minus x cubed over 3 evaluated from 0 to 3. So that's going to be 45 minus 9. So the volume is 36 cubic units. Are we good?
Yeah.
Cool. All right, and we'll do the next one tomorrow. And I'll work on 15.2 and 15.3 notes for y'all. Also, I'm almost done writing y'all's tests, so that's going to be going up today. And also, did y'all hear about the special announcement that the governor's making today?
No.
No,
Shelter
please
in
do
place.
tell.
Please God.
The gym's back open.
No. I'm afraid it's gonna not be great news. Like, we just got an email from our dean saying that we need to prepare for a shelter-in-place order.
Oh, damn.
Yeah, so yay.
Wait, what
So,
time?
What
it's
does
gonna
that
happen
mean?
at 11 o'clock.
Shelter in place means don't leave your freaking house.
Right.
Like,
you can only go out for essentials. So
Wait, what time?
I think it's supposed to be 11. I was told 11:30, but the email just got said 11. So
Cool.
So yeah. So just letting y'all know that this might suck more. So yay.
I appreciate you letting us know. When and where can we watch this address?
I'm assuming if you just Google it, if I can find it between my classes, I'll email y'all it.
That would be wonderful. Thank you.
Yeah. So I know that she done like town hall meetings, but you had to like call in so you could ask questions, which was stupid. It's like not everybody has a landline, so how is that gonna work? But so yeah, I'll see if I can find more information on it and let y'all know if so that way y'all can stay a little bit informed. And I'm sure once they announce it, the school will issue another formal announcement. Just think the sooner y'all know, the sooner y'all can prepare for things.
Mm-hmm.
So, yeah. But yeah, so I mean, we'll still be meeting and stuff and whatnot.
So what you're saying is I should go out now and panic buy everything.
Yes, that's what I'm saying now.
Okay, when I'm brought up in a court of law on charges of, whatever the resource hoarding is,
Yeah.
whatever they're going to end up charging me with, I'll make sure to mention you.
Nah, you'll be charged with battery when you beat up an old woman for toilet
Yeah.
paper.
I saw lots of videos of people beating people up. So don't be one of those people.
Got it.
You'll be okay.
Beat people up.
No, Angelo.
That's the message I'm hearing.
I need to stop recording this.
Those people.